All right, so I wanted to record a short video to show you where the formula for the determinant comes from, like the 2 by 2 determinant. So it comes from solving a 2 by 2 system of equations. So let me remind you, if you have a matrix, let's say A is equal to A1, A2, B1, B2, then the determinant of A, it's equal to, and we cross multiply, we get A1 B2 minus A2 B1. The notation for this, we also write it using like straight lines, A1 A2 B1 B2. Now, it is believed that Kramer was the first one to discover this formula when trying to solve a system of two equations and two variables. So say you have a1x plus a2y equals a3, and then b1x and b2y is equal to b3, and you're solving for x and y. So what you do is, well, you multiply the first equation by b1 and the second equation by a1 so that you can get rid of the first variable x. Okay, and then you solve for y. So what I'm going to do is, conveniently, I'm going to do second equation multiplied by a1 minus the first equation multiplied by b1. Okay, so if I do that, I'm going to get a1 b1x plus a1 b2y, it's equal to a1 b3 minus, and then the first one multiplied by b1, so a1 b1x plus a2 b1y, it's equal to a3 b1. When I subtract them, I get rid of x, and I end up with a1 b2 minus a2 b1 times y, it's equal to a1 b3 minus a3 b1. So from here, you get that y, it's equal to this right-hand side, a3 b1 divided by a1 b2 minus a2 b1. So notice that this is actually the definition of the determinant, right? It's exactly the same. So the reason for that, and this is why it's called the determinant, because if this a1 b2 minus a2 b1, if this is not equal to 0, then you know that this system of equations will have a solution. And if it is equal to 0, then you know that the system of equations does not have a solution. And this is true for higher dimensions. Like if you have an n by n system and the determinant is equal to 0, then that system does not have a solution. Okay, so this is why it's called a determinant, because it helps you determine whether the system has a solution or no, or not. So that's one. And the second one is by computing the area of the parallelogram formed by A and B, two vectors in two dimensions. Okay, so if this is the vector A and this is the vector B, then they can form, copy paste, a parallelogram, right? Copy paste. Oh, beautiful. So this is the area that we're looking for. Okay, now this area we also define as the determinant. Okay, or we can also define the determinant by the area of this parallelogram. So let me do a couple of things here. So first of all, since this is A, then this vector from the origin, this one will be A plus B. So let me draw it. Maybe let me draw it blue so that I see the difference. And let me use this so that it's pretty. So that is A plus B, okay? Maybe move it a little bit. Whatever, that'll be A plus B. Since this is the vector A, since this is the vector A plus B, then that means that it has coordinates A1 plus B1, A2 plus B2. So then that means that here, that means that down here, right? I'll have A1 plus B1. So this right here, this will be A1 plus B1. And this up here, maybe more careful, this will be A2 plus B2. What else do we know? We know that since this is the vector A with coordinates A1, A2, then this has to be A1 and this has to be A2. And then the vector B with coordinates B1, B2, then this has to be B1. And then this has to be B2. Okay, perfect. All right. So why does this matter? It matters because I'm going to compute the area of the parallelogram. I'm going to say area of the parallelogram. It's equal to the area of the rectangle that I'm about to draw here. So the area of this rectangle, right? Minus the area of this little areas, okay? So this is going to be equal to the area of the rectangle, which is A1 plus B1 times A2 plus B2. And then I'm going to subtract the other areas, which are, let's see, here I have, let me call this 1, and then this triangle, and then here I have a rectangle, so this is 2, a little triangle here, 3. What else? I can have here, let's see, another triangle, 4, a rectangle, 5, and then another triangle, 6. So minus the areas of 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, so maybe let me write it down here so that I have more space. Okay, but this is the idea. So let's see. So this is equal to, well, if I expand the left-hand side, I get A1, B2 plus, no, I get A1, A2. Let me do it in order. A1, A2 plus A1, B2 plus B1, A2 plus B1, B2 minus, and I'm going to compute each of these areas individually. So let's see. For the first one, height is B2, and then base is B1. So I have B2 times B1 divided by 2. So B1 times B2 divided by 2 plus. I go to the second one. I have the height is A2 plus B2 minus B2. So it's A2. And the base, so I have A2 and the base is B1. So A2 times B1. Number 3, the base is A1 plus B1 minus B1, so it's A1. And then the height is A2. So it'll be A1 times A2 divided by 2 plus A1 times A2 divided by 2. And I'm done with 1, 2, and 3. Let's see, 4. The, the height of 4 is A2, A2 plus B2 minus A2. So it's B2. Let me write it because I feel like I'm going to forget. So B2 is the height. The base is A1 plus B1 minus A1. So the base is A1 plus B1 minus A1. So I get B1. So B2 times B1 divided by 2. B2 minus B1 divided by 2. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4. Wait, 1, 2, 3, 4. So 4 is this. So the height is A2 plus B2 minus A2. So I get B2. And then the base is that. So that's the one I just did. I'm going to do the rectangle now. So now this is equal to A1 plus B1 minus A1. So it's equal to B1. So this is B1 times, and then this is A2. So B1 times A2. Perfect. And then 6, that's the last one. It's equal to, what is 6? Base is equal to A1. Height is equal to A2. So A1 times A2 divided by 2. And now we simplify this thing. So let's see, what do we have? Is there anything that we can just simplify real quick? Well, let's see. A1, A2 plus A1, B2 plus A2, B1 plus B1, B2 minus B1, B2. So this B1, B2 and B1, B2, that gives me one of them. So minus B1, B2. And then I have um, plus A2, B1 plus B1, A2. And then I have these two halves. A1, A2 divided by 2, A1, A2 divided by 2. So that is plus A1, A2. So this is equal to, and then we have to cancel a bunch of things. Let's see. So A1, A2, A1, A2, A1. Wait, don't forget that this was inside this. So these are all negatives. I try to save some time and then forgot to put the negatives. These are all negatives. So I put all my negatives here. Boop, boop, boop. So A1, A2, they go away. What else do we have? A1, B2, A1, A1, B2 does not go anywhere. A2, B1 minus A2, B1, B1, B2 minus B1, B2. And I'm left with A1, B2 minus B1, A2. Oh, which is A1, B2 minus A2, B1, which is the determinant. I think it's funny because I sort of forgot what I was doing. Okay, perfect. So this is equal to the determinant of A1, A2, B1, B2. So I think it's so interesting how this same formula shows up in a lot of different contexts, okay? Hope everything makes sense.